Hello again and welcome. In this second part video, we're going to be discussing another technique of solving the true number sum problem. We have this array of numbers and, to be more precise, distinct integers. And we also have the target sum, which is in this case 14. Basically, in order to solve this problem, we don't need to use a hash table as we did before. What we need to do here, we need to sort the array. This is going to come in handy and we will find out in a moment. To do so, we can choose one of the common sorting algorithms out there, let's say quicksort, merge sort, or heap sort. Knowing that these algorithms will take O of n log n time to sort an array. Then we proceed to find the answer to the problem we have. Okay, we have the sorted array. We place one pointer at the front and another at the end of the array, and because the array is sorted, this corresponds to the smallest and largest numbers respectively. In this case, we've called them the left and right pointer to make it easier to follow along. And in each step, we calculate the sum of the two numbers being pointed to. So let's start with -5 and 13. We sum up these two numbers and compare the sum to the target. So the result is going to be 8. So, if the sum is less than the target, we want to increase the sum by shifting the left pointer to the right. This brings the sum closer to the target value. If, however, we were to move the right pointer to the left, the sum would have been brought down. This is because of the sorted array, remember? We shift the left pointer to the right and move on to the next case, which is 3 plus 13. The sum is going to be equal to 16. In this scenario, our sum is larger than the target value. We want to decrease the sum by shifting the right pointer to the left. Again, with another two pair of numbers, we sum up 3 and 9 to get 12. We compare 12 to our target value, which is 14. Obviously, this 12 is less than 14. So what happens now? We move the left pointer to the right and move on to the next case. The right pointer is pointing to 9 and the left pointer to 6. The result of adding these two is going to be 15. 15 is greater than 14. We shift the right pointer to the left. In this case, we're left with the left pointer pointing to 6 and the right pointer pointing to 8. The sum of these two is going to be 14. And 14 is equal to the target value, which is 14. Since the solution has been found, we can now return the answer. The answer is 6 and 8. In case we don't find any, the left and the right pointers will eventually point to the same number, and we would have explored all the possibilities and we would have no pair of numbers to return. In terms of time complexity, we were able to go through the array in O of n time, and before that we had to sort the array, so technically we are limited to O of n log n, which is the runtime of the fastest sorting algorithm. And in terms of space complexity, this technique uses one of one space since no additional structures were created.